Hello, hello, hello. Hello, hello, hello. Oh, there we go. Finally good. Okay. So today's going to be a different type of a stream. Today is going to be about commenting the code we've done thus far and placing it in collect folders and stuff like that. So I'll be mainly talking about everything that has been done rather than making something new. I have 3-part series planned like this. First one's going to be commenting. At some other point, I will do tidying up the code. That's where we'll delete anything that's unnecessary, etc., etc. And then final one is going to be optimization, where I'll look at Profiler and try to make the code work, but use less resources. That aside, there's still several mechanics that need to be done, but yeah, I feel like I'm getting to the point where I really have to work on balancing the game, adding the levels and stuff like that. So I want to take it slower. I don't want to rush anything. I want the series to be complete. So I decided to do a little break series. I've also decided to start the next game making series at some point this week, simply because I don't have enough to do, and I first need to get the wave system going, the tower is balanced, and only then I feel like it can progress. So yeah, let's have a look at all the code, see what it does, comment it, and that'll be today's hopefully done within an hour session. Tomorrow we will be adding in more code to the project, but for today, yeah, that's it. Okay, so what we have here, starting off with our very first set of classes in the first folder, we have our enemy def, enemy health, and enemy movement. So what does enemy def do? Enemy def is our little flying enemy angel. And what this does is it allows it shows that the enemy has died through by when he gets killed. So if you place some towers down, you'll see that we have like this little angel flying into the sky, and this is exactly what it does. So this takes a starting position of the living enemy, how fast the enemy flies to the sky. Of course, we no longer need this, and what this essentially does is makes the enemy's death angel 3D visual fly upward to showcase his passing being killed, like so. So when we start, what this simply does is it triggers the object being destroyed after half a second, disables the trigger when this object becomes disabled. And what this does is sets the object to inactive, so we can reuse it later using the pooling script. And finally, an update makes the object move upwards based on the speed value, like so. So this is our little enemy script, and now let's go into enemy movement. This is quite a big class. You can get rid of these guys. So this handles enemy movement as well as any debuffs that slow the movement of the enemy. So first we have path to travel, and that's the path that the enemy has to travel through, which is taken from the map. Now, current position ID based on, and we have a speed at which the enemy moves. We have start and end position starting. I don't think we use start position. Oh, we do. But whatever. The starting and ending position, no. Starting and ending node position. The enemy within the array of nodes have to travel, like so. Do we use? Yes, we do. No, we don't. I think don't. This is not used anymore. This can go, doesn't it? Yeah. I don't think start time is used in either anymore either. Now that I think about it, it's a relic of the past. Yeah, let's get rid of it. So what actually is our end position? End position. The node that the player wants to move towards. See, I don't even remember it. Haven't used it. So the value of the slow. So for this specific game, we just chose to have a constant slow speed, which is half of our current speed. Why? Uh, it's just simpler that way. There is no need to mess around with stuff. So how fast is the enemy moving at currently? The 3D visual of the enemy being slowed down. And finally, reference to the scriptable object. No, the reference to the health class that takes in debuffs and damage. Now, let's grab here, make a little space. So this is sets up the enemy when it's enabled by attaching health, and it's enabled by setting up the path and all the start up values such as speed. Controls the movement of our character by moving it from node to node. And so what we have, so since this code is slightly bigger, so what we have here checks if, well, this doesn't make sense in English, checks if the debuff freeze is currently applied to the enemy. If it is, changes the speed to slow speed, like so. What we have here, and this is where our path happens. So checks if the enemy has reached the end of the path. If so, it destroys the enemy and player loses a health. And then here we have our movement. So moves the enemy by checking how far the enemy is from the current node point, like so, and then finally sets new node for movement when the player gets close enough to the node. And with this, we have commented our enemy movement, and let's have a look at the enemy health now. So what does enemy health do? Enemy health does quite a bit of things, actually. This could be split into a separate class if it was slightly, well, if the game was bigger, the debuffs could be itself its own thing. But it's okay. So handles any damage dealt to the enemy as well as any debuff applied. So let's get rid of that one. And what we have, so stores all the debuffs that are currently applied to the enemy. There. stores the pooling script that triggers the def object when the enemy dies. What do we have? Health transform. I believe health transform refers to what is health transform? So that's the UI canvas attached to the enemy that displays health above the enemy. So since we have this here, I feel like these two should be moved up. Like so. There we go. And then what does burn effect does? It's the visual representation of the player being, well, of the enemy being under the burn debuff. Like so. Scriptable object that contains all enemy information such as health or speed values. Stores the current health of the enemy so we can subtract from it when the enemy gets hit. There we go. And then we have our 3 of these, which is fine. This shouldn't be here. This should be. At the very top. Like so. Reference to the active camera on scene. So what this does is gets the main camera that is currently on the scene, sets the default start values such as the health and health bar, such as health air bar, when the object is disabled, it stops the debuff check function. Pass variable passes a variable that removes health from the current health pool, kills the enemy if health reaches 0. Do we do an update? Forces the health to look at the camera and checks for debuffs. And runs the fire debuff burn. Like so. Adds a debuff to the list of debuff if the current debuff doesn't already exist within the debuffs list. And then this is our function, so checks through all debuffs and applies their effects while subtracting from their remaining duration of debuff. Updates the health bar, and yeah, that's good enough. So that's what our enemy health does. Now, this will go back to the variant because structure-wise, this seems very messy of a folder. So let's go to main menu first and see what we have here and see. So maybe the settings shouldn't be in main menu. I think I should have my own folder for user settings. Where are we? User set. So I'll first comment them and then move them around. So what do we have in video settings? So users video settings for resolution, screen size. It's unnecessary, so I might as well just remove it. So what we have here, we have the preset resolutions available for the user to choose from. We have here from in height and width, text resolution. Also, the text that displays what resolution user can choose from. The iteration of the resolution based on height and width array. A toggle button that switches, that is responsible for switching full screen on and off. What else do we have? A value that checks for the toggle value that is attached to the full toggle selection, used for saving the state of full screen. And now that we have this, let's make some space. Sets up video settings default states, and set the next resolution. Preset the previous. Yep. Sets the text that shows what the current resolution is. Set the full screen boolean to match the toggle when the toggle is interacted by the user. Confirms the changes to the screen resolution and 1v1. I wonder what game. Let's have a look. Okay. Oh, I think he means Age of Mythology. Oh, lol. Confirm the changes to the screen resolution. Screen resolution and screen size. Okay, next option we have is our sound settings. So handles the sound music of the game settings. So what we have here is the text that displays the percentages of sounds, etc. Okay, what we have here is the sliders that control the settings of sounds. Oh, and finally the values of I get so distracted now with the messages and the values of sound settings. What else do we have here? Loads default sound data. Wait, since we're loading the default sound data from the save system, does that mean we're doing the same with the video settings? Or have I not programmed that in? Because if not, I'll have to. I didn't program that in. So that's something I'll have to add to my to-do list. It's great that I went through this because I would have probably completely missed out on this. Where's my little to-do? Okay, let's have a look. So let's forget about the old stuff. So make it so that video settings can add read from users default resolution and read from his presets that were saved in the old session. Kind of just going to split that into two, like so. Drag that to the side. So what do we have here? Loads this sound data from the save file. But that being said, no, because we will always load something before we'll always save something when the game starts, so we can never have an issue with doing that. Sets the sound based on the what's in it? What does where do we pass through? Oh, oh no, that's fine. It says the sound of the selected slider. Iteration refers to the ID of the array in the such as sliders and sound float. There we go. There you go. I got confused for a second with what it does myself. What do we have here? Confirm sound changes and saves them to our files. Handles interacting between option windows and panels. Stores all panels that change between videos, sound, and gameplay settings. Yeah, sets gameplay to be the default panel to show up. No, not gameplay, video settings. Handles the change of settings based on the number of the button that gets pressed, 0 to 2 values. It sets all the panels to in disabled. There we go. What do we have here? Oh, main menu. I feel like doing this will take more than an hour, so I won't be able to comment all of them in one go. The main menu handles the first scene that loads when the game opens, which is the main menu. There we go. Stores all the panels that get triggered when the buttons within the menu get pressed. So we have, what does the return button do? Triggers a function which disables all the panels besides the default one when it opens up the game scene. No, start game does opens up the panel that displays, that allows the user to select a level. So this is the triggers. No, so it sets the selected level as a player prefab, so it can be loaded into the game scene, loads the game scene, and checks if that level is default or user made. Opens up the map editor scene. Used as a return button to go back to the default state of main menu. Enables the options panel and disables the default state of main menu. The application. Save and sound. What do we have here? Initializing. Yeah, I feel like I'll actually have to split this into two parts because there's actually some announcements that I do want to make. So what do we have here? Initializes and handles default data saving and generating files. References the save the game data holding script. So what this does is it loads a file, loads a save file if it exists. If not, it generates a new save file. I don't need this debug log here anymore. What do we have here? Temporary to be deleted. Now what this does is it stores all gameplay changing settings. Of course this is empty for now because we didn't really do anything here yet, but it's going to be there soon. So I'll move all of the settings into a settings folder. It just makes more sense. Did we make a settings folder? User settings, yes we did. So main menu, because user settings will be in the game scene as well, not just main menu, so it's a bit confusing. Later on, the user settings will also work on the pause menu. Okay, let's go into map editor. Oh, that's going to be fun to talk through. So camera controller is going to be moved to utilities straight away because camera controller gets used in 2 separate scenes. So what we have here, let's start with the path editor because it's by far the smallest. So the object that stores each individual tile within the editor. So the number, so this is the component that stores a 3D number visual, stores all available tile types, which are grass, path, and dirt. See terrain type enum. Do I use height and width of the tiles? No, we don't actually care about this. Go away. It's unnecessary. We'll remove that right now, actually. Yeah, this is what happens with code. Eventually, it just becomes obsolete. You change things here and there and here and there, and you kind of just forget about it if you don't actively get rid of stuff. So the default types of terrain available stores these currently set terrain type. That's fine here. Sets the default map block. Yeah, that's good enough. What do we have here? Sets the correct block based on the in terrain type in. What we have here resets all the blocks by setting them to inactive. Sets a new block. I feel like I could have just done this there. Okay, let's leave it at that. Maybe change it later. Next, we have our big class, which is actually fairly commented. Stores the drop down that allows the user to select the level being worked on, the height and width that gets saved into the save system, the message that gets displayed if not enough path points exist within the level. Yeah, that one will need a lot of work. A set of default values of panels and names and level properties. Sets the idea of the selection, yep, which allows user to change the type of block when interacted with the ground, with the map blocks. But this makes the editor panel visible, makes it visible to have more space. Sets the level ID based on currently selected level. Sure. Saves the current level to the user files. Yes. Resets the level to empty and deletes it from the... Yes. Handles left mouse click for placing tiles. Yep. 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 So that's actually pretty decently commented. What do we have next? Create a map. So, we have the map generator. I think I'll stop for this one and I'll finish off the rest still today, but in a separate session. What do we have here? Stores all the blocks that have been added. Used for saving and getting block number. A transform which acts as parent. Used to parent the blocks to it, so the inspector is not as messy. No, hierarchy. Hierarchy. Checks if a map is already generated or not. We have here stores all the blocks by their ID used for saving the level. That we have here sets the default values and instance of this class, resets the message of resetting. No, this is not what it does. Sets the generated slash unload level button to default state, sets the to generate level message. I'll copy this because I'll want to do the opposite of that in a second. Sets the default values of the map and the parent. What do we have here? Deletes the map to the visual blocks. Sets the height based on the... I don't think it's a slider, or is it on the slider? It is probably. I need a quick break before I continue, so I'll just mute myself. Oop. Sorry for the delay. Forces of nature were stronger this time. It's weird because it's like my internal clock has shifted for this matter, but let's not go into this. So 20 more minutes of this. What do we have here? Set width. So sets the width of the slider. No, sets the width of the map to be the width value of the slider, and that's exactly what the other one does too. Okay, there we are. It checks. Yep, shows all the numbers. Wait, does it? Checks how the map will be generated. Yep. Show all the methods. Show all the numbers of the paths when loading a map with ready existing path. Loads the file. Loads map from save file. No, it does. Yeah, it does. It generates the new map. Yep. And that's our editor that we have here, map generation. So map generation is map generation. It's basically the same thing as the other one, although slightly simpler. So the start and wait, what's this for? I wrote this so long ago that I don't even know. Is this even necessary? I don't think so. Well, this says one reference. I mean, I guess if it's useful. What does it do though? Oh. Oh. Used for determining last and first block in the map. That's what it does. Sets all the blocks to be disabled. What do we have here? Oh, sets the correct block as well as tags them appropriately. Sounds kind of weird. Tags it appropriately. What's it called? This no longer used. A parent for the map blocks so they don't make the hierarchy messy. ID of the level to be loaded. All the tiles that have been spawned within the level. Again, hyphen with. Wait, it is being used. Why is it? Oh, it's because there is a. So, how tall and wide the map will be. Nope, don't need you anymore. Sets up the default values and loads settings from player prefs. So what do these guys do? Used for loading the default block data unloaded level. What's that? Used for loading the default pathing for the enemy from the loaded level. I'm kind of thinking now, do the default levels still work? They should. I'll have to check this out later. What do we have? Generated level. Yep. That's a big one. We can actually, so if our level is default, it uses scriptable data to assign width and height. Otherwise, it loads all the data from the save file. So that's our first set, and this is where the map gets generated. It generates the map based on our height and width assigned. And what does this bit do? Sets the path of the level based on the method in which the level was loaded, like so. And what do we have here? It sets the starting and end block of our pathing for the enemy. The reason why we have the start and end point is because we actually place a little visual. So let's just load in a level and see what's going to look like. There we go. So our start block has this blue little marker and the red block has a red one. So if we press play, the enemies will walk from our start. Well, this is where they generate, and they'll finish at the red where they will die and take away from their health. Go on, guys. Make your way downtown. Actually, let's speed up their process. And there is like, yeah, like so. Actually, something that's not implemented in the game. Add end screen. Well, lose game and end game screen. And which also means add in score to the game, possibly. Like so. Okay. Now with this done, what do we do next? Map generations, okay. Oh, let's have a look at how the game gets saved. So for saving, we are using system.io. Oh, I feel like this one's going to be properly commented. So we can ignore these three values. They're used for just the naming that we use for saving. So we have level related. So for level, we have a function that sets up the level. And then we have a function that saves the level using binary formatter. So we open a binary formatter, we open up a file stream, and then at the end we serialize the data and close the stream, and that saves the entire data. We have one for deleting the level. Currently we only use it as a tester, but we will actually add that into the gameplay settings later on. This is because we also use it in the editor. The editor allows you to delete the level as well. So there's two places where the ability to delete exists. It's the delete save that we do in the main menu, and this is used for the other one. So let's hide that and open that one. What we have here saves the data. I really like using regions. I'll definitely do that later when I'll be cleaning up the code. It just lets you open related code, keep it together. But yeah, this is basically the same thing as the one above, but it's just used for saving all of the data. And this is loading of a level data, which should be in the level related one. So let's just move that out of here. No, it's load user data. Never mind. But then why is player saving region ending here? It shouldn't be. It should be ending here. Where are we? Okay, well, there you go. So this stores the player data. It's very simple. We have a array. So that contains all the user information. And this stores all the values. So our master sound, which could be like 0.5, 0.3, normal sound, which whatever, resolution and whatnot. I guess the biggest problem here that it's all floats. The reason why they're floats is because, of course, the sliders of sounds are values between 0 and 1, whereas the resolutions are integers. That could be easily changed by timesing all of these by 100, and when saving them and then dividing them when loading them in, and then changing that to int. For a game like that, it doesn't really matter. So this one's slightly more complex. So what we use here is not a standard array. We use, what do you call this array? It's not a jagged array, because jagged array is the one with a, what's it called? With a comma, I think. I think this is just like a double array, whatever it's called. It's basically an array of arrays. So this stores all level information. This only stores the path of the level. Now, this stores the blocks within the level and their type. Well, we just store in the number. So like 0 is grass, 1 is path, 2 is dirt. And then stores all other values within the level, like height and width. So what we do here is at the start, we set the level to 3 because we have 3 arrays in here. So we put all of these 3 arrays in here. So we have 0 is our size data, which is the first array. Yeah, so that takes the width and the height, like I said. Then we have our paths and blocks. That one takes in the number of path points, which we get from the level editor. If we remember, where are we? In the editor. I'm not going to open it because it takes too long, but in the game editor, we have, there we go. We have block IDs here, and we had another one for path. There you go, number of paths. They're both lists. So what happens here is we literally just, wrong class. We take them in, convert them from a list to an array, and assign them to that. And then we do at the position 0 is going to be our size, 1 is blocks, 2 is paths. And then once that's done, it can just get saved into our saving and loading scripts, like so. And then, of course, we get to the final class, which is the class that saves and, well, I guess they're both like interconnected. So the other one's not attached to a game object and it does all of the magic. And this one is connected to a game object. This one carries over from one scene to another. And there's actually a little bit of an issue here. So what's this called? Save Data Manager has multiple instances in one scene. So right now what the problem is that we just make instance to this and we do don't destroy unload. We open up the main menu, it does that. We move on to the next menu, it doesn't which is the game scene. It doesn't destroy this object, so now we have 2 instances, which is not what we want. We only want 1. So this needs a little bit more code, which I'll add later. So what we have here sets the instance of the object and deletes any other ones if there is more than 1 present. Of course, it doesn't do it just yet, but it's what it's meant to do. So instance of subject, which allows us to reference it from different classes easier. Now what we have here, a value of the music within the project. I'm actually just gonna copy that across for 1, 2, value of sound. It's funny because master sound does absolutely nothing currently, and I don't think it will, because I really don't want to delve into options for sound too much for this project. Let's remove the serializable fields. I only had them because I needed to test some values out. when I was working on this. So value of the full screen or window mode, and then value of the index which corresponds to a specific screen resolution. We definitely have to still add more to the resolution parts because they're far from done with loading. But yeah, so what do we have here? Sets the instance, yeah, that's fine. Sets the volume, yep. Sets the master sound of the game. Yeah, master, I don't know. What do we have here? It sets the settings for the screen size and resolution. Save the user, yeah. So this literally is called when we want to save data. All it does is saves, and this is the loading. I added a try catch here because if the data doesn't load properly, it'll throw a massive error. And it's usually hard to debug them. So I just try and catch them just in case. Also, sometimes when the data doesn't load, the game can still play in some instances. Like if the sound setting doesn't load, it's not the end of the world. But yeah, but if there is no try catch, it will just break the project in its entirety, which is not what we want. So what do we have here? The base classes, yay. So there's 4 set of scriptable objects within this project that we use. Let's start off with the enemy. So let's get rid of that. Scriptable object of the enemy within the project. So an enemy consists of a name, health, speed. They have their own icon and they have a value of how much they're worth. If there is a point system, they also have that, but if not, we'll just count how many enemies we've killed overall, which doesn't have to be connected here. And how is that represented within the game? Well, if we go into our resources folder and into enemy prefabs, there we go. We have a lot of different enemies. And if we click on them, we will see that they all have base enemy attached. And there is different types of base enemies. Now, to create one, a scriptable object, we just right click, select an enemy, click on it, and that generates a new enemy. And what's great about this, we can change their health in the inspector. So I can set his health to be 300, his speed to be 2, worth 50 on kill, like so. And that allows us to create a lot of enemies very simply with their stats. Because if this was an actual class attached to the object, like a normal base class within the thing, we would actually have to, well, we would still have to we would have to serialize the class for start. So let's open an enemy health and just quickly show how that would work. So an alternative way to do this would be to have I guess a class called public class test enemy, like so, and we would have public int health, etc., etc. And then we would just do system dot serializable to be able to see it. It would do the exact same thing as a scriptable object right now. So if we go into an enemy, we should be able to see this. Where are we? Of course, we would then, so we have that, we would then, of course, have to call it. So we would have something like public, let's just make it public for the sake of testing public enemy. Is it enemy test enemy, new enemy, and it would be something like this. Where are we? There we go. And then we could attach, yeah, set his health, etc., etc., and that's how it would look like. But with a scriptable object, there you get something like this. I think it's nicer, easier to play around with. But and you don't have to make a constant difference of prefabs. So with this application, the one I showed you, we would have one prefab for one enemy type. But with this one, what I could essentially do is, instead of where are we? And we could actually do that later on. So here we have one enemy, and let's just assume that we don't want to have so many prefabs of an enemy. We just want to have one prefab of an enemy. So what we just have to do is switch this out for a different one in enable. And that could be easily done by having a script that places the correct enemy type into this box rather than having to drag in every individual enemy. And now that I'm talking about this, that sounds like a very efficient system to add enemies to our load system. So I might actually go with it in the next part. So let's just write that down. Load, nah, you know what? No point. I already did a different system. There's no point going back. But yeah, that's scriptable objects for enemies. So like I said, there's 3 different scriptable objects. First, we have for our towers, they follow the exact same structure. So object for a new tower, scriptable. Now, what do our towers have? So towers have identity. Now the ID gets used to select the correct tower. For selecting this specific tower, the name of the tower, which is when we place the tower, we can click on it and it will just show you what tower it is. There is no actual point to this besides for the user to see that it's called the axe throwing tower. The description, again, does the same. And the reason why the description is so that the player can know what the tower does, because as a developer, I know what all of these do. I programmed them. But someone who's never played this before, they would probably be like, oh, well, it looks like something. The icon doesn't really tell me much because the guy clearly has no skill in paint. But if you click on the description, it'll be like, oh, well, it shoots out several shots in different direction. That makes sense. There you go. For the upgrade system, I literally did what I talked about previously with the enemies. So I've created a class inside of the scriptable object, and I moved all of the values such as damage range and rate of fire inside. And that allows us to have multiple upgrades that get controlled by a number inside of the actual tower class. Bullet speed is a brand new variable that I've added. It just allows us to control how fast the bullet moves. Although I don't use that for every single tower, and this is because not every tower has a bullet system, and some towers use, even though they use bullet systems, they can't have a speed that can be altered because they travel in a different way, like the cannon tower, which uses the power bullet to move in. It can only travel between 0 and 1 values. Actually, that's why I think it would be nice to set up a range. Well, can't really set 0, but we can set a max. And what I'll do here is I'll do public float max range. Can I do that? Is this possible? Nope, impossible. Well, let's just set it as a 30 for now, and that's it. So what this does is it actually creates a slider. It's really fun. to use. Where are we? So if we go into a tower, we click on any of these, and there we go. Now bullet speed is a slider, as opposed to nothing that was previously. And let's set that to 5 by default. There you go. Great. What do we have? The buyout cost is how much it costs for the tower. Sellout sells. Pretty self-explanatory. So this, let's comment. This handles the upgrade system of the tower. Now, level stores are default levels. So before, if we go back to parts, I would say 5 to 7, we had a level system that was manageable using, well, only the Unisys hierarchy. Since then, we've converted it so you can actually build it within the game. But we do have a remnant of it that we use, which is the old level system. So with the old level system in the editor, we would add the same things that we are now adding to a file. However, we would add them to the scriptable object instead. And of course, scriptable objects are sets of data that only exist within the project until it gets compiled. When it's compiled, it's an asset. It's not a piece of data that can be modified. It's an asset instead. So it would have been impossible to use the editor after the game gets compiled. And later on, I decided I want the user to be able to do that, but I still wanted there to be some default levels because you don't want to have a tower defense game with no levels. So I used the old system to create 4 levels that user can always use, but he can override it with their own levels if they choose to, using the editor system. So this is the source, the default levels existing within the project. And of course, we have the height and width of the level, the source, the log paths of the level, and finally stores the path for the enemies. Like so. And moving on to the wave, this is by far the simplest scriptable object. So it just does one thing: it stores the enemies within a wave. So it only takes in one single game object, and that's the enemies that we spawn. So let's have a look at this real quick. Go into scriptables. Here we have a level. Nope. Into the waves, and here we have a wave, and here we literally have what that enemy will have. So our wave manager will loop through every single enemy, spawning them one by one. So 1, 2, 3, 4, 5 until the very end. Now, the cool thing about this is that we can create levels. Well, it's not the quickest way to create them, but we have complete control over what kind of a level we create and how we want it. And we can choose which levels we load, which not, in which order, so we can test very easily and efficiently. So if we look at level 5, for instance, we have 20 enemies. We start the game off with 10 enemies of tier 1. We then have 5 enemies of tier 2, 4 enemies of tier 3, and a boss enemy of tier 4 for this specific level. And then if we go into our game scene, click on our wave manager script, we can see that where are we? That we have each wave added in. If we want to, we can only have one specific wave, and then all we have to do is just adjust the money, the starting money in the game manager. So testing becomes much quicker than it would with other approaches. Okay, with this, we have hit our 1 hour mark. There's going to be a part 2 of this where I go over the remaining classes, and once that's done, we will work on, I would say, adding more towers, I believe, fixing some of these issues that we came across within the today's session. Whereas for the second game that's going to be made, which will start sometime this week, is going to be a Mario clone. I'll try to find some assets of Mario game assets that we can use. Now, since this is for educational purposes, I can just steal directly from it, and I'm pretty sure somewhere on the internet there's going to be all of the animations for the Mario, as well as all of the blocks separated how we need them for this. But yeah, I'll be back again tomorrow doing part 2 of commenting, and then we'll think which coding parts we'll do next.